Hey everyone, today I'm going to show you how to perform and explain the rainbow in a bottle experiment. And here we're going to be using a graduated cylinder. So the materials you'll need are the graduated cylinder, sugar, 4 separate cups, and 4 different colors of food coloring. So I've already taken the liberty of putting the amounts of sugar into each of these cups. For the color that you want to be on top, you're going to want to use no sugar. The next one down will be 2 tablespoons of sugar. The next one down will be 3 tablespoons of sugar, and the final one is 4 tablespoons of sugar. So let's go ahead and put the food coloring in. You're only going to need about 2 drops. And then you mix it up. And you have to do this for every single one. And you want to add the colors at the end so that the stirring rod you use, and I used the glass one, but you can use anything as far as a mechanical pencil, in order to just stir it in, and you don't want to be mixing the colors, so just wait until the end for those. Alright, so that was green, now we'll do yellow. Okay. One of the really important things with the rainbow in a bottle is being slow when you're adding on the top layers, because if you're too quick with it, the layers will mix and it will be ruined. So that's why we do it with a pipette, which I'll show you in just a second. Alright. So first things first, we're going to put the most dense, the blue, into the graduated cylinder. So just get a nice bottom layer here. See, graduated cylinders work better than beakers or glass jars, even though those would work, because you need a lesser volume to get like a considerable height on, or width of your little bands. So put a little bit more because we have a lot. But you don't need to use everything in your cup. I only used 50 milliliters in each cup, but probably only put about 10 to 20 in. The bottom should have the most. Right? And I just oriented them in the color of the rainbow, you know, Roy G. Biv. Alright. So now, here's where it gets interesting. So, you want to pipette it in, but you also have to do it down the side to make sure that it's not too much force that it goes down with. So you have to pipette it very slowly to make sure that you don't mix the two. And soon enough we should start seeing a little green layer. Right now it looks like they're mixing a little bit, so let's hope we get a little bit of a green layer. The green looks like it's just mixing, so we'll try the yellow, which has a greater density difference. So, I can see a little layer forming on the top. You have to be patient with it and just go very slow. If you get impatient and try and go faster, they'll just mix together. So as you can see, we're starting to get a distinctly different layer on the top, so we just gotta keep it up. We're getting a green, and I assume this is the mixing of the yellow and the green. See, because you need a significant difference between the two liquids in order to make sure that they separate. I'm just being very cautious because I know if I get hasty, they'll mix together and it'll ruin it. can go a little bit faster. Once you've got that separate layer, you don't have to be as careful because you have a little bit of a barrier, but you still can't be too hasty with it. And then hopefully red, having no sugar, will also be able to make this separate layer. Alright, now I don't want to jostle it too much, but you should be able to see a distinctly separate layer there on the top. There's a blue and then there's a little green. Alright, and now we'll try and add a little red. So you can see this one takes a while, so you just have to ask the kids to be patient with you. So let's go down the side. It's important that it slides down the side because otherwise it'll pick up speed as it goes down, and then that'll ruin it'll mix them together essentially. The further down in the graduated cylinder you can get, the better. It's the less time it picks up speed as it goes down. So you can tell because this is only water, it's going down a little faster, but I do start to see oh, and it's even better pictured in the camera, a little layer forming of red. Alright, so I'll stop torturing you guys. So as you can see, you get those nice distinct layers. Unfortunately, green was not as extreme a difference as I would have liked it to be from the blue. So you weren't able to see a little separate. I'll actually move out of the way. But you can see you have 1, 2, 3 distinct colors there. And that's really what you're going for, just to show them that you can separate the water based on the density. Now let's get quickly into the explanation. So what happens is that a liquid with a greater density will sink to the bottom, and one with a lesser density will rise up. So as long as you don't disturb the careful balance between the two, because there isn't a chance that if you try and pour it or add it too quickly, the two will mix together and just equalize the sugar densities by diffusion. But if you're very careful with it, they'll stay separate and it looks pretty neat. Alright, I hope this helped you both perform and explain the rainbow in a bottle experiment.